Exercise, limits at infinity of quotients with square roots. All right, so the notes for this exercise are basically the same as the one for limits at infinity of quotients. All right, you want to look at the variable with the greatest exponent in both the numerator and denominator, and you can ignore the other terms. The only difference here is that you have to check the plus minus sign for plus or minus infinity. All right, you want to remember that even exponents will result in a positive number, and square roots must be positive as well. All right, so you'll see what that means more specifically on the exercise itself. All right, so they want us to find the limit as x approaches positive infinity. All right, it says it right here, positive infinity. So just like last time, you want to look at the greatest exponent and ignore the other terms. So here's x squared. Let's ignore this. Here's plus 1. And we have these two terms here. Now, we have the square root of 4x, squared, and that's divided by 4x. All right, square root of 4x squared is just 2x, and that's divided by 4x. X's cancel, x over x, and we're left with 2 over 4, or 1/2. Now, that's not necessarily the answer, because you want to check and make sure that you're dealing with positive or negative numbers, okay? Square root of 4x squared has to be positive, and this can be positive or negative, but we are going to positive infinity. All right, so actually on this one, we don't have to worry about the plus minus because it's positive infinity either way. Okay, so even though radical 4x squared is always positive, we're headed to positive infinity, so it doesn't matter. So in this case, the answer is just 1/2. Pretty simple. All right, so same function, I think, but x is going now to negative infinity. Okay, we're going to do the same steps. Ignore these smaller exponents. All right, and we have radical 4x squared over 4x. All right, radical 4x squared, square root of 4 is 2. Square root of x squared is x, and that's over 4x. And of course, that just equals 1/2. Now, there's a small problem here. This x is going to negative infinity. But when you plug in values right here in the numerator in place of x, even though x is going to negative infinity, this right here is going to positive infinity. Why is that? Because it's x squared. All right. So even though this goes to negative infinity, this here goes to positive infinity. And the one on the bottom, negative infinity, yes, that is just x as is. It's not squared. It's not to the fourth. It's not an even root. So this one does go to negative infinity. So in the denominator, it's negative. Positive divided by negative, as we know, that's a negative. Okay, so unlike problem number 1, this one actually goes to negative 1/2. All right, so once again, we're going to negative infinity. Once again, ignore these smaller exponents. Look at the numerator. The greater one is 6x squared. Look at the denominator. The greater one is 9x to the fourth. Okay, so we have 6x squared. And we have radical 9x to the fourth. All right, 6x squared. Radical 9 is just 3. Square root of x to the fourth is x squared. X squared over x squared is gone, and 6 divided by 3 is just 2. Now, again, be careful. if you take negative infinity and plug it in there, the exponent is even. It's x squared. So that one is positive in the numerator. All right, let's just make this 2 over 1 for now. And this is 9x to the fourth. That's an even exponent when you plug it in there. Even though x goes to negative infinity, this is also positive. So yes, positive over positive, it's still positive 2. All right, here we're going to positive infinity. And ignore these smaller exponents. So ignore 4x squared, ignore negative 1. We have radical 9x to the sixth. And that's divided by x to the third. Square root of 9 is 3. Square root of x to the sixth is x to the third. And that's divided by x to the third. X to the third over itself cancels, and we're just left with 3. Now, positive infinity, if you plug it in here, it's still positive in the numerator. If you plug it in here, it's still positive in the denominator. Positive over positive is still going to be positive. So 3 is okay.